Welcome to the Hydrogen Podcast, where we explore the latest in hydrogen technology, investments, and infrastructure. Today, we're honored to have Bill Newsom, President and CEO of Mitsubishi Power Americas, joining us. Bill is at the forefront of Mitsubishi Power's effort in advancing clean energy solutions, and today we'll dive into the opportunities and challenges that lie ahead for hydrogen as a key energy carrier. Welcome, Bill.
Thank you, Paul.
Appreciate
Excited
it.
to be here.
Thank you
for having me.
So, diving in,
Sure.
Mitsubishi Power has made considerable investments in hydrogen and clean energy. Can you give us an overview of where capital is being deployed both in the Americas and globally? And how does this align with Mitsubishi Power's broader vision?
Well, first of all, I've been with Mitsubishi Power 20 years now, and I've been in the industry for 30 years. And I'm really proud to be working for Mitsubishi Heavy Industries and Mitsubishi Power Americas, a company that's committed to net zero by 2040.
Mm-hmm.
And one of the reasons why we're doing that is so that we can develop solutions and products to enable our customers and our partners to meet their net zero goals by 2050 or so, right? And so as a company, we have had a 3-pillar strategy. And that 3-pillar strategy is 1, to help develop a hydrogen ecosystem. 2 is to be part of developing a CO2 ecosystem. And then 3, to decarbonize existing assets. And so we are spending hundreds of millions of dollars to develop new technologies and solutions to come down that cost curve and bring low carbon solutions to bear. And each one of these 3 pillars, we have real projects that we've been executing on. And if I can take a moment and talk about each one of those, the first one, over 5 years ago, pre-IRA, we invested significantly to develop a hydrogen production storage facility, utility scale, and out in Delta, Utah, called ACES Delta. And so we'll talk more about that today. And then the second pillar, which is the carbon capture ecosystem, we are in the tail end of a FEED study for a significant project in Decatur, Illinois, that I look forward to talking more about that one as well. Yeah. And in the third pillar, the decarbonizing of existing infrastructure, we partnered with EPRI and Georgia Power, and they have 6 M501G gas turbines, and we went and trucked in hydrogen, and we're able to, very few modifications to the existing plant. We were able to blend 20% hydrogen and bring down the CO2 emissions. It actually helped combustion and low load. We demonstrated across the load range. And so having that blend of hydrogen with very minimal changes to the plant just shows that we can actually lower CO2 emissions for existing facilities as well. So those are some of the areas we're really working hard to demonstrate these new, lower, cleaner technologies.
That's great. Are there any regions that are leading the charge when it comes to hydrogen investment that you find especially promising? What can your company learn from these efforts?
Let me take a moment and take you to Takasago, Japan.
Yeah.
That is where we have our MHI DNA, is that we always design, test, and verify at our own facilities. And sometimes it's challenging because our process is that we demonstrate for a full year before we take a product commercial. That's the MHI way. And that's why our reliability of our products and solutions are so high. So we have built a 101 combined cycle power plant, spent billions of dollars there to demonstrate our latest gas turbine. And on top of that, we have the world's first hydrogen park. We spent over $50 billion building this facility. And in this facility, we're doing 3 things. 1, we're testing and verifying and developing 4 new hydrogen production technologies. We're demonstrating above ground storage and then utilization in 2 different avenues. 1, we've got an R&D center there, and then we'll run hydrogen through single can combustors and make sure we can manage the fluctuations in combustion vibration on 1 can. And then on our fully commercial 101 combined cycle JAC combined cycle power plant, we're utilizing 20, 30. We're now in the next few months going to demonstrate 50% blend on that commercial power plant. So in summary, we are really looking, I can't promise you we're going to bring 4 different hydrogen production technologies to market, but we're going to go spend time and effort to see which one works best.
Right.
And there might be a different answer in different parts of the world globally.
Right.
High pressure alkaline, AEM, pyrolysis, and SOEC, solid oxide electrolyzer cells. So all of those we're testing and demonstrating now.
That's fantastic.
Yeah.
Hydrogen production has come a long way, and the push for green and blue hydrogen is strong. How does Mitsubishi Power differentiate its hydrogen production technologies in this evolving market?
One of the things that we look at is we don't really differentiate between a color.
Right.
Hydrogen, whether it's blue or green or pink or magenta, all of them are reducing CO2 emissions,
Right.
and we want to support all of them.
Yeah.
Right now, we, as I said before, the ACES Delta project, we are currently in commissioning of 40 high pressure alkaline electrolyzers out in ACES Delta, 2.5-hour drive outside of Salt Lake City, where Intermountain Power has a renewable project. They're shutting down an 840 megawatt coal facility and repowering with 2 1-on-1 JAC gas turbines. And then across the fence, 5 years ago, we started this development partnership with Magnum, and we have developed, and we're commissioning now 2 salt caverns that are the height of the Empire State Building. Each one of them stores about 150 gigawatt hours of energy. And so we're going to take water, curtailed wind electrons, split that water into hydrogen and oxygen, store the hydrogen in the salt cavern, and then utilize it. Day one, it goes commercial in 2025, and we'll be blending that renewable hydrogen with natural gas and then sending those renewably fueled electrons through a high voltage DC line down to the LA basin. So we're able to help decarbonize the Western United States. So that's at scale project where we're shutting down a coal facility, repowering, and we're able to demonstrate new scaled technologies, de-risking those technologies. And this was pre-IRA.
Yeah.
So making those economics work is really important. And, I think on the blue side, we have significant carbon capture technology for carbon capture on the tailpipe of gas turbines. And pre-combustion carbon capture is also very important. And figuring out the cost, we have an abundance of natural gas in the United States, arguably 150 years. So if we can figure out how to take curtailed renewables, make green electron, make long-term storage, and utilize those when it's needed for lower carbon electricity, we can take natural gas, we can carve out some of those CO2, make blue hydrogen, and utilize that. And where it makes sense on the tailpipe, where we can store CO2, if we can use natural gas and then capture that CO2 and store it, geographically, where the geology makes sense, is where some of these answers are better, more cost effective.
Absolutely. What are some of the most exciting advancements in hydrogen production you've seen in the past year or two? How is Mitsubishi Power adopting or innovating around these advancements?
One of the things we're working quickly on is hydrogen utilization in a gas turbine and the production of hydrogen. So pairing those together, very important. So advancements we're looking at, as I mentioned, out in Hydrogen Park with 4 different hydrogen production technologies, and then the utilization. It's a challenge to utilize hydrogen in a gas turbine. The flame speed is so much faster than methane. So making sure that we can test and verify that and manage the flashback and get all the way to 100%. That's going to take time and effort. So we're continually working on that at Hydrogen Park and T Point. And I'm excited about, we're going to demonstrate 50% blend. And so we're able to do that with a combustor that, this gas turbine ships ready to go with 30%. We're going to have to change combustors when we go above 50% blend. One of the things I'm excited about is the hydrogen production technologies. Hydrogen production electrolyzers have been around for 60 years. But they've been bespoke and they've been small. So bringing those to scale, is going to be important. That's what we're doing out at ACES Delta. And we've been operating the same electrolyzer for almost a year now at our hydrogen park. So we demonstrated that before
Nice.
we installed it out at ACES Delta. But when we look at the cost of hydrogen, green hydrogen specifically, we've got to come down that cost curve. So we're estimating over the next decade, we need to bring down the cost of electrolyzers by 80%.
Right.
So those are some of the areas we're looking at in terms of improving manufacturing, scaling up, and reducing the cost of electrolyzers as well.
I'm really looking forward to hearing more about the hydrogen park too. All
Okay,
the
sure.
new advancements that you have going on over
Yeah.
there.
Love to take you.
I'd love to see it.
Yes, you have
Love
to
to
come
see
and
it.
see it firsthand.
Absolutely. Can you share Mitsubishi Power's strategy regarding electrolyzers? Are there plans for scaling up production or possibly even leading innovation in electrolyzer technology? And you did kind of touch on this a little bit.
Sure. And yes, we've invested in Hydrogen Pros technologies for the 40 electrolyzers we've already installed out at ACES Delta. And it's been in operation in Hydrogen Park. So we are continually looking at how do we improve that technology and how do we make it more efficient and bring it to utility scale. Because when we first put it in operation in Hydrogen Park, we did have some challenges and we had some bumps in the road, but our design team got all over it, worked through it, and we ran it through all the paces up and down, and we saw some of the challenges and we fixed all those challenges. So all those fixes we brought in, and we have worked with Hydrogen Pro, and we've modified that, and those all got installed out at ACES Delta. So I'm looking forward to the commissioning of those electrolyzers here right now and into beginning of 2025. Be great to even have you go out to ACES Delta and see those 40 electrolyzers in operation out there.
Love to see that too.
Yes, yes.
So given the race to achieve cost parity with fossil fuels, what role does Mitsubishi Power see itself playing in making hydrogen production economically competitive?
Great question. And I think if we step back for a minute and look at history, if we look at our electric grid, over the last 20 years, we've reduced the CO2 emissions in our electric grid by almost 50%. And how did we do that? We did it by shutting down coal, replacing with natural gas, and adding renewables. And technology was the enabler there. We were able to use shale fracking technologies to bring down the cost of natural gas. And so that fuel switch was economical. And it solved the math problem of clean plus lower cost electricity. And so that's where I think we are today with hydrogen. You're hearing a lot about with data centers extending lives of coal plants and utilities and developers building hundreds of gigawatts of natural gas plants. It doesn't necessarily feel clean today. But the thing that's great about this is we are going to install this generation. We've got these hyperscalers demanding and going to hold us accountable to have a path to clean. So yes, we're putting in gas today because they need electrons today to grow this AI platform. And that's going to be the forcing function and the driver to get us to clean. And so we've got to crack the math problem of clean plus secure plus affordable. And so we're focused on that every day. What can we do to de-risk technologies, bring them to scale, and come down that cost curve? But we have to be pragmatic. It's not going to be overnight. We're going to flip a switch and be able to have zero CO2 emission in the United States and be able to serve data centers and also power your house and our businesses, right?
Switch it up a little bit again.
Sure.
Hydrogen storage and transportation are key challenges for scaling hydrogen. How is Mitsubishi Power addressing the issues around hydrogen storage, particularly the infrastructure that's needed?
Yeah, hydrogen storage. I mean, one of the great things out at ACES Delta, the geology around the United States, and we've studied it quite a bit, where there's salt domes. And we're blessed with really great geology out in Delta, Utah, where we have this enormous salt dome that could house up to 100 of these salt caverns, each one storing 150 gigawatt hours of energy. That's enough to power the entire Western United States. So think about that for a minute. That massive salt dome, and if we were able to tap into that, and we could power the entire Western United States. And as we've studied it, the salt caverns are really the most economical long-term storage for hydrogen. We've been doing that for a long time in the United States with LNG liquids as well
Right.
too. So liquid natural gas. So that is a cost-effective way to store hydrogen.
Mhm.
And the Gulf has some other salt caverns. So we're looking at salt domes. And we do think that, there's other forms. Above ground storage is expensive,
Right.
dedicated. You can do pipe packing, and if you're able to build a long pipe when you don't have the right geology underground,
Right.
is an option as well. So these different forms of storage we have been studying and looking at the overall economics for projects to go forward.
Excellent. We've seen developments like hydrogen pipelines and ammonia-based carriers. Which storage and transport methods do you believe have the greatest potential for scale, and how is Mitsubishi Power positioning itself with respect to these technologies?
Well, our hydrogen development team is working on projects to utilize both and looking at regions where we have ability to put hydrogen pipes,
Mhm.
as well as, MHI is investing in, we have a shipbuilding part of our
Yeah.
division and is looking at ammonia carriers. And oh, by the way, we're developing an ammonia burning gas turbine as well. So we've got in Nagasaki, we've got also a demonstration facility where we've got carbon capture and ammonia turbine that we're demonstrating there. So I do think that a big opportunity in the United States to help decarbonize other parts of the world is to take renewables, make green hydrogen, convert that to green ammonia, and then ship that overseas in countries like Japan that do not have the resources to decarbonize themselves.
Yeah.
And their government's looking at contract for differences and being able to help support paying for that additional cost to create the green ammonia, ship it over, and then utilize it with our ammonia turbine over there.
Yeah.
So those are some of the things we're working on.
That's great.
Yeah,
The cost of hydrogen remains a barrier to adoption.
correct.
What steps is Mitsubishi Power taking to reduce these costs, and what role does policy play in making hydrogen more viable economically?
I think I've talked a lot about what we're doing in Hydrogen Park and demonstrating technologies and looking to come down that cost curve so we can reduce hydrogen production cost. Policy is very important.
Yeah.
And, one of the things that makes it challenging for additionality is that if we have to build a dedicated renewable resource, then it does make the cost of hydrogen very challenging.
Right.
If we're able to use curtailed renewables, where we are building we're building almost 36 gigawatts a year of new renewables will go in the ground, PV, solar, or wind. And so being in certain areas when those renewables aren't needed, they're curtailed. If we can take and utilize those, convert it to long-term storage, that is one of the most significant ways to reduce the cost of hydrogen. And so policy that supports that is something we have been working with DC to try to convince them of the right policy. And so I think getting the policy right is important. And so we'll see what what comes out in the next administration. But I firmly believe that production tax credits, and I heard a couple speakers earlier today mention, and I'm going to paraphrase from them, that we're in this long game. And I agree with that. When you look, I mentioned before, about 20 years, we've reduced our carbon footprint. At that same time, we had production and tax credits for renewables, and they were very expensive.
Right.
So over 20 years, we've come down that cost curve. And that's where we're at now with hydrogen.
Yeah.
We need to, 20 years, come down that cost curve.
Right.
And those production tax credits have lasted over many different administrations. And I feel that's going to be the same way with hydrogen and carbon capture. As we go forward, this decarbonization journey is not going away.
Right.
And that's why what's changed significantly in the last 12 to 18 months has really been the demand growth by these hyperscalers. And I think that's a good thing.
Yeah.
Even though it might not feel clean today, it's a good thing because they're going to demand clean.
Right.
Pragmatically over time. Because if we force them to pay for clean today, it's not going to be economical. They won't pay for it.
Yeah.
So they're going to give us time to get the cost right and bring these technologies to bear.
I couldn't agree more. Yeah. So how do you see hydrogen working alongside renewables to provide economic and environmental benefits? And where does Mitsubishi Power fit into this integrated vision?
First of all, where we fit is I mentioned before, we have a 3-pillar strategy, and we
Yeah.
are fully committed to making this hydrogen ecosystem, and that is needed with renewables being a key part of that.
Mhm.
Driving the green hydrogen production, we need to have PV solar and wind to be the source for converting those curtailed renewables into long-term storage. And we have a hydrogen development team. We have a PV solar development team. So we're focusing on developing those projects that make sense to go forward. And before I said we're developing 4 different technologies for hydrogen production. So we see that the alignment of renewables with baseload generation and peaking firming generation is really important to do.
Yeah. One of the things that you had said that kind of piqued my interest
Sure.
was how treating this like a transition,
Yeah.
right? And with the turbines that you have now and starting to blend hydrogen, you're giving
Right.
that initial use case for hydrogen,
Right.
whether green, blue, it doesn't really matter. It's the
Right.
molecule itself. So you're really at that front door of that hydrogen transition,
Right.
and that you're really alongside with renewables as they're generating that hydrogen, being able to utilize it right then and there
Correct.
through those turbines.
You're exactly right. And I think that's one of the, you touched on it perfectly. It's a gas turbine.
Yeah,
It really doesn't care what the
Right.
gas is. As
exactly.
long as we can control that combustion, that explosion in the
Yeah.
combustor, and manage that appropriately, and it has lower emissions,
Mhm.
that's what we're focused on every day.
Fantastic.
Yeah.
Thank you, Bill,
Yes.
so much for sharing your insights and expertise with us today. We've covered a lot of ground, from investments in the landscape around those investments and the latest technological advancements shaping hydrogen's future. As we look ahead, it's clear that Mitsubishi Power is playing a crucial role in driving the hydrogen economy forward. Before we wrap up, do you have any final thoughts or messages that you'd like to share with our listeners about the future of hydrogen?
Sure. I am extremely proud of my team because we have been working very hard to develop this technologies and solutions for the path to clean. And we've got significant utility scale projects for hydrogen, green hydrogen, we're going to bring to commercial operation next year. And I think that's really, as you said, leading the charge there. I'm looking at can we continue to solve the math problem of bringing reliable, secure, and clean
Mhm.
energy to the marketplace. We're going to continue to invest hundreds of millions of dollars in technologies to be part of that solution, come down that cost curve so we can deliver on those 3 key goals.
Yeah.
So thank you.
Absolutely. Appreciate it. And thank you again for being with us, Bill. And to our listeners, be sure to stay connected with Mitsubishi Power for updates on their exciting work in the hydrogen sector. Don't forget to subscribe to the Hydrogen Podcast for more conversations with industry leaders as we continue to explore the world of hydrogen and its role in the energy transition. Stay tuned for upcoming episodes.